Hi, I am Matīss, and today I'll share some work done with my colleagues Edison and Rinalds about how we annotated food-specific tweets in Latvian from multiple aspects. So first, I'm going to introduce the presentation. I'm going to talk about the project overview, how the data was collected, processed, and annotated initially. And then I'll talk about our specific annotations introduced in this paper for sentiment analysis, named entity recognition, text-image relations, and machine translation. And then finally, I'll show some results from experiments using these newly annotated datasets. So the project of food Twitter tweet data collection was actually launched in 2011 and has been running mostly smoothly ever since with little restrictions. It does have its own website. You can go check it out. Even though it is all in Latvian and collecting the data about Latvian, it does have a button for English translation. So you can try to understand what happens in the dataset. It even has its own Twitter account, and which tweets every day the 5 most mentioned foods in the day, 5 most active users, tweeters of the day, and even just before lunchtime, a random recommendation of a food, drink, dessert, and some other food product for lunch. It was facing difficulties with the leadership changes recently, but at the moment, everything is fixed again and more data is coming in every day. The main track keywords for the dataset revolve around eating, breakfast, dinner, appetite, just food related, the bold ones. And then additionally, we added several most popular foods such as oranges, apples, meat, cake, sour cream candy, rice, and so on. Overall, there are around 300 keywords being tracked to collect this dataset. So the dataset is publicly available on GitHub. It's published according to Twitter's guidelines, where only the IDs can be published, but then later anyone can gather the actual full data themselves. It is domain specific, specifically about food and eating, and it is written in Latvian, which is a very highly inflectional language, relatively less resourced and less spoken language with only under 2 million speakers worldwide. The dataset is around 2.5 million, but still counting and still growing every day. And then it has several subsets for annotated sentiment and so on, as well as 150,000 for tweets with images and 170,000 with location information. The interesting part of the dataset is the yearly distribution, because in the beginning, when the project started, the first few years, there were around 500,000 tweets coming in every year from the API. But then seemingly Twitter became less popular. People started abandoning it, and only really dedicated users stayed. And it reached a very low point in 2018, having less than 50,000 tweets in that year collected. However, since 2018, it does seem to be being growing again year by year, reaching over 100,000 tweets in the past couple of years as well. The red and purple lines and the black line for TikTok are from Google Trends, which is the overall popularity of the search terms in the region of Latvia. And it can be seen that while popularity for Twitter goes down, popularity for Instagram goes quite high up, and also TikTok goes up. So it can probably be assumed that when some users are leaving one social network, maybe they're migrating to another and so on. This is how the data is processed. So for each tweet, there is an ID, the main text, the tweet author, and the created date. Some tweets have image information, so they contain the URLs to the images. Some tweets have location information, and they have the country, the actual location name, and the longitude and latitude. And then finally, for each food item in the tweet main text, we store the surface form of the food, the nominative form, since Latvian is inflectional, and each food item can be inflected into many different forms. The food group, which is basically just a number from the basic food pyramid, and also the English food translation for just easier processing and analysis further on. So getting into what we did in this paper, we were looking at text-image relations images were only added in Twitter in around 2013. Before that, people were using TwitPic or other services to post just links to images. So native only came relatively later in the service. And then in the beginning, in the first 2 years, it seems like many people tweeted with images, reaching like high peaks around 2016, over 20%. And then it sharply dropped to 2019, 2020, around 5%. However, recently, there has again been a resurgence where around or over 10% of tweets contain images attached to them. And then when the tweets contain images attached, so what can we actually learn from these images? So we decided to utilize a schema of annotation where to annotate 1 out of 4 different classes, where the first one, the green button, would be that the text is represented in the image. So what is written in the actual words can be seen in the image. And then the image adds to the meaning of the text. So something that is in the image is not written in the text, and then only by seeing both together, you understand the whole picture. The gray button would be where text is not represented, but the image adds to the text. So the text talks about something, and then finally the image shows the actual whole picture, what's going on. And then further, the purple button, which would probably represent this image right here, and text pair, where the text is represented in the image, but the image doesn't really add any more meaning to the text. So here we see the text talks about a bun, banana yogurt, and cutlets, and that is exactly what we see in the image. So it's represented. However, image doesn't really add any more meaning to the text that's described there. And then finally, the red button would be that neither the text is represented in the image nor the image adds to the text, which can commonly be perhaps just complaining about something and adding an image of a meme, which is completely unrelated, or something completely different, unrelated as well. So these were generally relatively rare. Most common were either green button or the purple button for our annotators. And then once our annotators annotated around 810 tweets with image text relations, we decided to finally try to ask vision language models whether they can handle this task. So for example, another tweet text pair would be the image of the cat here, and then the text would be rough translation in English, eat breakfast well, eat, which is probably what the cat is thinking by looking at its master, that they're eating breakfast right now. But when you just read the text, you don't really understand what's going on. And then when you see the cat, it doesn't make sense for just the text alone or the image alone, but together they actually complement each other. So we are prompting the lava model, where given the text extracted from the tweet in Latvian, does the image add to the meaning, yes or no? Or is the text represented in the image? And again, yes or no. Since the lava model is originally for English, we did try both the original Latvian and automatic translations into English, where we saw a quite high increase in the accuracy from 21% average to about 28%. But overall, that's still quite a low accuracy, and there's still lots more to be done there. Because in general, at least for humans, this doesn't seem such a difficult task, but perhaps for the vision language models, it's not always very clear and understandable. We also tried to use the very latest level 1.5 version models and the 713 billion parameter versions of those. And then we also tried to run them with multiple different seeds. Overall, these achieved lower scores than the level 1.0 models. Still, the English translations were higher than the original Latvian text. Interestingly, the 7 billion models were outperforming the 13 billion models on this task. Then further going on for named entity recognition, we annotated 744 tweet test dataset, which was originally had only sentiment annotations. We added the named entity, location, organization, person classes, and miscellaneous items as well. And then once that was done by 2 separate annotators and by a third annotator who will help resolve any conflicts, then we trained a multilingual BERT model for named entity recognition and evaluated the model on this data set. Overall reached quite a high accuracy of 84.41%. And then we fine-tuned that model specifically for the Latvian tweets, and the accuracy got improved a little bit to 85.71, which still, both of those numbers are quite high in the grand scheme of things. Then going to machine translation. So we again used the 744 tweet test set, which at the moment had sentence analysis and also named entity recognition annotations. Then we manually translated it into English. And afterwards, there was another person manually collecting and post-editing it where necessary, just as a quality assurance measure. And then finally, we decided to evaluate several models, both open source and online closed models, using this data set to see how well they can perform on internet noisy tweet dataset text. Interestingly, the MBART model was the very lowest, significantly lower than the others. However, the OpusMT model was already quite close to Google Translate, and then the tilde-M machine translation model was the very best out of all 4. And then finally, we come to sentiment analysis, where it's actually seemingly quite difficult to determine sentiment of tweets, even though sometimes they are just 1 sentence or 2 sentences long. So for example, the lower one, if you want to lose weight, just pull out your teeth, then it's going to be difficult to eat too much. It is about eating, but I guess about food. However, it does seem like a recommendation, so maybe something could be positive. However, it recommends to pull out your teeth, which does sound like quite a negative action, and recommending to make it yourself difficult to eat too much. So is it negative? Is it neutral? Is it positive? This can be kind of discussed by annotators, so it's not always very easy to distinguish which sentiment class should be added. We wanted to also have a timeline balanced data set for sentiment analysis. So we selected 50 random tweets from each year between 2011 to 2020. And then we asked 12 individual annotators, all native speakers of Latvian, to annotate these tweets. And then we used the majority vote for the final annotation label. The overall agreement of annotators is quite high, 70.48%. And then the free marginal kappa was also 0.56, which is considered intermediate to good agreement. So we're very positively surprised about that. However, there were a few instances where they all disagreed, and then we chose just the majority labels. And then again, to see how well language models can handle such sentiment analysis tasks, we fine-tuned the BERT model with the multilingual BERT, and interestingly, it reached over 86.4% accuracy on this dataset task. And then we also tried to evaluate each individual annotator according and against the majority vote, and that reached just over 80%. So seemingly, the BERT model is overpowering the individual annotators at this task. We looked at sentiment over time in the whole data set of 2.5 million tweets. And interestingly, in the beginning of the data set collection, it was quite overwhelmingly positive, and a lot of neutral tweets and very little negative tweets. But that slowly changed over time, and the positive tweets went quite down, and then there have been resurging a little bit again, but the amount of negative classified tweets has been growing over time. Interestingly, the neutral tweets went up to a peak in around 2017, over 60%, but again, also have been going down ever since. So the conclusion, we extended the evaluation sets for the Latvian tweet reader dataset corpus by supplementing the original sentiment analysis dataset with named entity labels and full English translations, and also manually label completely new an image relation task and a timeline balance and analysis task. For future work, we're planning to explore fine-tuning the LLaVA model or other text vision language models on Latvian or on tweets or on Latvian tweets, because this evaluation was the overall lowest of the tasks that we explored. And we feel that we can kind of achieve a higher score for that one. Everything we mentioned is open sourced on GitHub, from the website of the Twitter project to the main corpus, Twitter error corpus. The named entity corpus is in a separate repository. And then the sentiment analysis toolkit for training and fine-tuning the sentiment models is also open source, as well as the processing scripts for gathering and handling the data. So thank you for your attention, and then come by for the LREC to see the poster and talk to my colleague.